Hey guys, this video is just going to walk you through your post-lab questions and kind of explain where some of these numbers are coming from. Alright, so our lab has to do with finding our constant. And you should be familiar at this point with the fact that when you're finding this constant, it's important that you find all of your equilibrium values. Now you guys mix together some iron 3 nitrate, which provided that ion, as well as potassium thiocyanate, which provided that ion, in order to create this other liquid. So you had 4 containers, right? And you mix them in different quantities, which you know will give each of these different molar concentration, making that final solution. So we're going to have to look at those initial values, and we are going to have to analyze what you ended up getting after mixing those. Okay, and those are going to, all of that's going to be used in your ICE tables. This is a really good read. That whole paragraph, I can't stress it enough. It's important that you read it so that you know where a lot of this stuff is coming from. I will try my best to cover as much of it as I can in this video, but just in case, you know, it's worth reading because it does thoroughly explain a lot of this stuff. So it kind of tells you why certain things are going to equal each other. So it's kind of cool. So looking down here, it kind of starts running you through a bunch of random equations. And I just want to use this time to kind of show you that they're not random. And there's a reason why we're doing this ratio. And there's a reason why you have these subtractions. And they're honestly all things that you've already done before. So make sure you pay attention. I would write down some notes as you watch this video. Okay? All right. Rearrange my screen here. Push that off to the side. Okay, so the first thing that they're asking you for is to make sure that you have the right equilibrium expression. Okay, so if this is our formula, and I would have this really big in your post-lab area as well, you want to go ahead and start with your little expression. So you should know at this point that it's going to be products over reactants. We do not have any coefficients, so nothing will have exponents. But please make sure you are putting in those charges. Okay, so now that we have this, now it wants you to start calculating your different values. Okay, and one of the first things that you're going to have to calculate is going to be your initial molarities, because you also know, let me move this, actually I haven't just rewrite it. All right, so you know that you have this Fe okay. I'm going to go ahead and make my ICE table, and this will really hopefully clear up what pieces of information you have. So you mix those two things together. So you have certain initial values. Do you know where to find that? Hopefully you started looking at this nice little data table that you used in order to make it, your little recipe that you guys were using during the lab. Okay, so you are going to be using these values in your dilution formula, which is the M1V1, M2V2, to figure out those different concentrations. Okay, cool. Next, we know that we started with 0 of this stuff. Okay, now we know that we want to say our change is going to be a minus X for my reactants, and this one's going to be plus X. Okay? So we know that you're going to have Fe initial minus X for this. For this one, you're going to have SCN minus initial minus X to get your equilibrium values, because remember, this is what's needed in order to use your equilibrium expression. Okay, and finally you have 0 plus x, and you actually found this one in the lab. Okay, so reason I had you write this out, the things that you have to find right now for me are going to be this value, and this value. And I'm going to kind of walk you through the best I can how to find each of those. Okay? All right, so we're going to start with these top two values. Okay? I'm just going to move my screen up a little bit. There we go. That's what I was trying to do. All right. So in order to do this, those first two values, like I said, you're going to be referring to our data table that they provided to you right here, okay? And you're going to be doing your M1, V1, M2, V2. So I'm going to go ahead and just start with trial 1, okay? All right, or test tube number 1, your cup number 1. All right, so I know that I'm going to be using dilution formula, and this is going to help me find that mystery molarity right here. That's the guy that you're solving for. So what I'm going to go ahead and do is I'm going to type in, or plug in, sorry, the molarity of my iron nitrate, okay, which was given to you up here in your directions, okay, and it was also labeled on the cup. So that was a 0.002 molar solution. You put 5 milliliters in there. So 5 milliliters, right? We're going to move that decimal 3 to the left, so it's 0.005 when we convert it into liters. So 0.005 milliliters is equal to, we're looking for this new molarity, my volume 2, remember, we brought it to a total of 10 milliliters. Okay, we brought it to a total of 10 milliliters. So that would be 0.010. All right, so when you type this into your calculator, let me go grab a calculator real quick. Okay, typing it into your calculator, I multiplied these together and divided this guy over. Okay, so what I end up finding is my molarity is now going to be equal to 0.001. Okay, so remember, this is talking about my iron right here, okay? And this is my initial value that I'm finding. All right, so now what I'm going to do is I'm going to find it for my KSCN, potassium thiocyanate, okay? We're going to be referring to this 2 milliliters. This was also a 0.002 molarity. So let me go ahead and set that calculation up. Okay, so now I have M1 V1 equals M2 V2 again. Again, my molarity of this potassium thiocyanate was 0.002. Volume, to begin with, was 2 milliliters. So 2 milliliters is also 0.002. We set that equal to finding this new molarity, and final volume was 10 milliliters. That's what your solution was. So the concentration of my SCN ion, okay, and once again, this is an initial value, that's going to come out to be, let me type this in real quick, 2 divided by 0.01. I got 0.0004. And you can be doing this all in scientific as well. Okay, I'm using my phone calculator. All right, so now I have both of my initial values. Okay, so let's see where that takes us. in our ice table and see what pieces of information I actually collected. Okay, so in my ice table, what I just found was like I said, those two values, these two up here. I'm going to go ahead and erase this little spot. I'm going to actually add them in there so we have them. Okay, so what I have is 0.001 for my iron. And my thiocyanate, I have 0.004. Oops, forgot 1 0. There we go. Okay. Okay, so cool. So now I can use those once I find X. I still have to find X, unfortunately, right? So, so now we're at the fun part. Now we actually get to look at our absorbances to find this guy. Okay, this is our goal right now. That's what we're doing. So let me clear off some space. Make sure we've got this. Okay, so this is where we're going to bring in that weird formula that they gave us. Okay. Okay, so we're going to start using this equation, which looking at it, it kind of looks a little overwhelming. It's a little confusing as to where that actually came from, and it's not a random equation. I'm going to show you what that is actually, okay? So it all actually comes from Beer's law, which you guys have been working with that a couple times. It's not something we're completely strong at, but we do know at least that we can look at data from a colorimeter and look at those absorbances and say that they're directly proportional to your concentration. So you can kind of come up with a qualitative, slightly quantitative value for how concentrated something is, okay? But during this lab, what they actually are getting you to do is you're going to be comparing your equilibrium. That means, so this value right here, that's going to be the one that you got every time you tested a new cuvette. So cups 1 through 4, you got a bunch of different equilibrium values, okay? You're going to compare those to the standard. This was cup 5, okay? So let me actually label those so you have that. So this is going to be cups 1 through 4. This is all about cup 5. And you're taking a Beer's law and you're actually doing a ratio. If you see this, what I have written right here, I'm doing my equilibrium over standard. Okay? So, how the heck do we get that equation? Well, what happens is these guys are kind of like your constants. We didn't change anything about our colorimeter. We just changed what we put in there. So really, those guys we're going to eliminate. We're not even going to worry about them. Okay? We're just going to concentrate on this part. So what we end up having, if we were to rewrite this and make it a little bit prettier, okay, shrink that up. If we were to rewrite this, you would end up with your little A EQ over A standard. Okay, so cups 1 through 4 over cup 5, what you got from the colorimeter, equal to your concentration at equilibrium over concentration of standard. Now, where the heck did we get these values? Well, you're going to be solving for this guy. This is the one that we need for our rice table up here. Okay, that's the one that we need for the rice table. So that's our goal. We got to solve for that guy. Okay, the C standard right here is going to come from another dilution calculation. Call it dilution calculation, but we're finding a new molarity, right? And if you remember from the procedures, what you did, okay, was you mixed 18 mils of the iron nitrate, and it's 0.2 molar, and 2 mils of this 0.0020 molar KSCN. So we need to know what the concentration was of the iron 3 thiocyanate, okay? So what I kind of want you to imagine is that this little part right here, the 2 mils of this guy, that's kind of like the limiting reactant. So what we want is that this is going to determine how much iron 3 thiocyanate, this guy, right, what we actually want, it's going to determine how much we were making. I'm sorry, this one over here for the standard, okay? So I know that's kind of a bunch of gibberish, so if you just zoned out, I apologize. But what that means for you is that we're going to be using the 2 mils portion in this dilution formula. So you're going to go with the 2 mils. Let me get rid of this arrow so that you don't get confused. There we go. All right. So solving for the standard, you're going to use the 2 mils of the 0.002 molar KSCN in order to make a total of 18 plus 2, which is 20 mils. And you want to know the molarity, okay? So you're going to be doing that to find standard. Now, to go back to that equation that they gave you that I was trying to explain to you, basically, if you notice, okay, and I'm looking up here at this guy right here. Okay, so if you look at this that they gave you, all that this is this thing rearranged. Okay, it's this rearranged. If you notice, we're solving for the top one, so what do you do with the bottom one? He gets multiplied. Just like that, okay? That is exactly what they gave you. All right, so I just wanted you, if you just wanted to know how to do it, then just do it, and that's fine. But if you wanted to know where it was coming from, it's coming from a ratio of the Beer's law, and that's the way you're going to apply those absorbances, okay? All right, cool. So the only other part that you need, obviously, was I showed you you're going to be using dilution for this guy, for the standard concentration. These values are coming straight from your data table. So I went ahead and gave myself some mock data. It is 1, 2, 3, 4, and my standard is 5. Will it be way off from yours? Yes. What I would end up doing is for trial 1, I would for this little formula, I would go ahead and say this FeSCN2 plus equilibrium value that I need for the rice table is equal to my data table says for trial 1 I got 1 and my standard was 5 times this, okay? And so when you go to calculate, and feel free to use mine if you want, I'm going to go ahead and say 0.002 times 0.002 equals my other m, my new volume, 0.02. Lots of 0.02s. All right, so when I plug that in, I get that divided by 0.02. I get a molarity of 0.002. All right, this right here is going to be my FeSCN 2 plus standard. Okay, and so that value is going to go right here, and I would get that, multiply it, and I end up with the value 0.00004. Lots of 04s and 02s. Try not to lose your place along the way, okay? All right, so cool. So this is my equilibrium value. so I can finally go back to my ice table and use all this crazy data, okay? So just to make this a little bit clearer, I'm going to go ahead and make a new ice table. Okay, cool. And we've already determined that initially, using my M1, V1, M2, V2, I had 0.001, 0.0004. Okay, so 0.001, 0.0004, that one had nothing. Change was minus x plus x. So we're going to figure out what this value is. We're going to figure out what this value is. And this one we just found was equal to 0.00004. Please be using scientific notation. It will be so much easier than putting a bunch of zeros like this. All right, so now that we have this value, okay, we just found out what x was. Plug her in. Once you have all of those values, now you can solve for your KC. So hopefully this video helped a little bit. I hope I did not overwhelm you, but make sure you come in and talk to me if you need help. I would just take this video slow, write down little steps. You want 4 rice tables total. And honestly, for each of those, I should see all of this. Okay? Yeah, so I should see at least 3 dilution formulas. Actually, no, this one will stay the same. So you only need about 2 dilution formulas for every single rice table because you need to get these 2 initial values. Okay, so if you want the steps, here you go. You want to do ice table, or rice table, sorry, I keep telling you guys ice. Okay, in order to get your initial values, you're going to do your M1, V1 equals M2, V2, using that little data table that you used in order to set up this little data table right here. Okay, you're going to use M1, V1, M2, V2 to get your 2 initial values. Then you're going to use the Beer's Law thing. Okay, which was your equilibrium concentration was equal to absorbance over absorbance times standard concentration. Okay, once you have that, you finish ice table, as in you get equilibrium values. And last but not least, you solve for your equilibrium constant. You're hoping that the constant stays the same. That's your goal. All right, good luck.